Assalamualaikum warahmatullahi wabarakatuh. I am Ahmad Rasakmal bin Ramlan will present to you the development of heart rate sensor warning system to estimate driver's cognitive distraction level, which is my final year project 1. In Malaysia, numerous road accidents are recorded each day and resulted in being the top 20 countries in the world with the highest road accidents rate as of 2015. According to Malaysian Institute of Road Safety Research, driver's factor contributed a huge percentage of road accidents among all 5 factors with 80% as of 2018. The US National Highway Traffic Safety Administration categorizes driver's distraction into 3 types, namely visual distraction, manual distraction, and cognitive distraction. Cognitive distraction occurs when the driver diverts his attention from driving tasks to another mental workload task such as chatting with passenger, daydreaming, and talking on the phone using hands-free or not. It is harder to address the visual and manual distraction as it occurs within the driver's brain. Hence, in this study, the driver's cognitive distraction will be evaluated using appropriate approaches correlated to driver's heart rate to develop a user-friendly heart rate sensor warning system. Why this project is selected? It is because most of the existing research use simulator to get the data from the driving session because of the safety aspect. However, in real life, the real driving situation is more challenging than in the simulator. Moreover, the existing heart rate sensor is not convenient to use by the driver as the finger must be stuck to only one sensor at the steering. This gives a problem to the driver as it is hardly used as the sensor could not detect the pulse when the finger is not placed at the desired place. Then, based on the previous research, the number of respondents affect the result accuracy. Each participant carries their traits and habits that influence the driving performance. Thus, in order to achieve more accurate data, a higher number of participants is needed to get the best average result. Based on the problem statement, the objectives here are set to accomplish the aim of this project. The first one is to alert the drivers and increase their driving performance when they are cognitively distracted by using a heart rate sensor warning system. Then, to determine the relationship between driver's heart rate and their level of cognitive distraction that affected their driving performance. Lastly, to develop a driver's heart rate monitor with minimizing the interference of the driver performance. The scope of this project is to develop a heart rate sensor warning system to estimate the driver's cognitive distraction level without interfering the driver's performance. The input variable involved are reading of the participant heart rate and answer from the NBAC task, while the output are the result from the analysis using IBM SPSS statistic and ANOVA. However, there are several limitations to this project. First, the analysis is done using the BIM video game for the simulation and limited to Malaysian road culture for a real driving situation. Then, 16 participants involved which are 8 for the analysis using simulator while the other 8 using the real car. Lastly, 3 types of measurement involved in this project, which are performance measurement, subjective measurement, and physiological measurement. According to Don Yan Chow, there are 5 different measures on determining the driver's state of mind, namely subjective measurement, biological measurement, physical measurement, driving performance measurement, and combination of measurement. In this study, 3 of these 5 measures will be used in analysis, which are subjective measurement, driving performance measurements, and physiological measurement. For the subjective measurement, it is typically used to acquire respondent feedback on the experience or mental task when driving. There are also several techniques to evaluate subjective mental workload measures, including NASA TLX, RSME, and SWOT. The subjective measurement will be evaluated using the NASA TLX. It is the commonly used technique that rates performance according to 6 elements to determine overall mental workload rating on a like-a-like scale ranging from very high to very low. The table here shows the 6 elements to rate the driver's performance. The key activity in NASA TLX is to follow the weighting procedure by using the weight software to present the 15 pairwise comparison to the participant and requesting them to select from each of the 15 pairs the subscale from each pair that contributed the most to the workload of the task. The advantage of this technique is it provides a quick and simple mental workload measure. A change in mental state can initiate a change in driving performance. Driving performance measures quantify driving behavior and are commonly used to explore the impact of distraction. Speed, lateral control, and reaction time are common measurements of driving performance for this purpose. Based on the previous studies, the drivers with cognitive distraction may experience increasing, decreasing, or normal speed. However, there is no significant influence on lateral control such as lane switching. Furthermore, the reaction time of the driver was affected significantly, which shows an increase of time in each driver. The N-BAT task is used to test the cognitive workload of the driver. It is widely used in examining brain activity. It may be beneficial for examining cognitive load and driver distraction concerns. Moreover, N-BAT tasks are continuous recognition assessment in which participants judge whether an item in a stimulus sequence, such as letters or pictures, matches the one presented an item ago. Physiological measurement such as heart rate reading, EEG, and breathing rates has been used to detect drivers' distraction levels. According to various studies, heart rate and heart rate variability are responsive to cognitive workload and emotion. According to George Jahn, it has been demonstrated that heart rate is a good indicator of drivers' cognitive workload. The correlation between heart rate reading and drivers' distraction level is that a transition from low to high mental workload may reflect the changes in the activity of the autonomous nerve system, which is associated with a greater heart rate. In this experiment, the respondent heart rate or pulse rate are collected using the heart rate sensor warning system, which is the heart rate monitor bracelet. It alerted driver when there is changes in heart rate beats detected by the device and produce sound to aware the drivers when it is cognitively distracted. The purpose of the experiment is to study the correlation between heart rate and the cognitive distraction of the driver. The experiment is done using driving simulator as shown in the picture and also real car. There are two tasks that each driver needs to be done. For the main task, the driver needs to focus and drive safely, and for the secondary task, the driver will be given the N-BAT task while driving and answer it correctly. Difficulty level of N-BAT task will increase in each session of the task. There will be 0 BAT task, 1 BAT task, and 2 BAT tasks that will be given to the driver. The last session will be a 2 BAT task that will be conducted with an alarm device to alert the driver when their heart rate exceeds the threshold that will be set. In the 1 BAT task driving session, the driver's heart rate will be taken to set their heart rate threshold for the last session. The threshold of heart rate for each driver will be set by taking the average heart rate in this session. The last session will be conducted with an alarm device to observe any different reading of the driver's heart rate compared to other session. It will be discussed on the discussion if there is any significant difference in heart rate reading between the session conducted with alarm device and the session that does not conduct with the alarm device. The duration of each test is 6 minutes. For the 2 minutes, the driver just need to drive normally. Then for the next 2 minutes, the driver needs to drive and answer correctly the N-BAT task given. After that, for the last 2 minutes, the driver needs to drive normally and complete the test. After the respondent finish each test in each session, they will be needed to answer the NASA Task Log Index immediately to rate their performance of driving. Then, I will present about the expected result. Cognitive distraction will be measured through heart rate, whereby the mental condition of the driver will initiate the autonomic nervous system through the sympathetic and parasympathetic nervous system in the activation of increase or decrease of heart rate. The physiological measurement is a calculation that is related to the mind of the driver, where it shows the driver's level of alert. From the previous research, the heart rate of female is higher than the male when the experiment is done. It is expected that the heart rate of female remains higher than male, but both gender heart rates increase when driving in real car compared to the simulator, as it is more challenging to drive in real life. For performance measurements, it shows the level of driver's performance when cognitively distracted. From previous research, the driver's performance was decreased when performing the difficult level of the N-BAT task, which is the 2 BAT task. As this experiment compares the result of the simulator and real driving situation, it is expected that the driver's performance would only have slightly decreased than using the simulator, which has an obvious decrease in performance as the driver would tend to focus more on the road than answer the N-BAT task. The last measurement in this experiment is the subjective measurement, where it shows the driver's level of distraction. The previous research shows that male is difficult to distract than female, whereas male need more effort to be distracted. Thus, it is expected that driver's level of distraction will be increased when using a real car than using the simulator, as driving in real world need to focus more than in the simulator. That is all from me. Thank you.